As you can see here, 5 2-volt batteries are connected together in this circuit with 4 resistors with resistances of 4, 12, 10 and 8 ohms. Determine the following parameters. What is the voltage at A, B, C and D? What is the voltage across AB, BC, CD and DE? What is the current in the circuit? And eventually the battery will lose its voltage and falls to 8 volts. How much power will be dissipated in all the resistors together? So when it falls to 8 volts, how much power will be dissipated in all the resistors together? So how do you solve this problem? Well, firstly, to be able to determine the voltage at these various points, you need to determine the current flowing in the circuit. Well, this is a formula here, V equals IR, which by transposition, you know how to do that, it's I equals V divided by R. Right, firstly, what's the voltage? Well, we've got 5 batteries connected together, each of 2 volts, giving us 10 volts. So that's the voltage. Now, the resistors are in series, and obviously you just add them together. 4 plus 12 plus 10 plus 8 is 34 ohms. So now we know I equals 10 divided by 34, it gives us 0.3 amps. So we know the current throwing. Now we need to determine the voltage at various points. Now at point A, this would be at the same as where the batteries are. Again, we're going to ignore the resistance of the wire because it's negligible. So that at point A it will be 10 volts, okay, 10 volts. Now to determine the voltage at point B, we've got to determine the voltage drop through the first resistor using V equals IR. Well, we know the current's 0.3 amps and the first resistor is 4 ohms. You put them in there, you get a voltage drop between there of 1.2 volts. So there, 10 minus 1.2 volts, that would read 8.8 volts at that point there, it would read 8.8 volts. Now we need to determine the voltage at point C. We've got to determine the voltage drop through the next resistor, okay? We know the current's 0.3 amps and we know the resistor here is 12 ohms. Putting it in, it gives us a voltage drop of 3.6 volts. So we lose another 3.6 volts as it goes across there. So 8.8 minus 3.6, it gives us 5.2 volts. So if you took a reading there, it'd be 5.2 volts. Now we need to determine the voltage at point D. And again, we've got to determine the voltage drop through that resistor. And we know the current, we know the resistance is 10 ohms, therefore it gives a voltage drop of 3 volts. For 5.2 minus 3, a reading there would be 2.2 volts. Do you understand? It's 2.2 volts. So we have just worked out the voltage drop there. That's how you work out the current and that's how you work out the voltage drop. That completes electricity.